Afternoon.
Good afternoon.
Right. So I will try to relay this to the normal printer that we know of. When we're talking about print cartridges, right? This would be a cartridge when we're talking about a 3D printer. So this is PLA material, 1.5 millimeter diameter. So basically the printer will take this material, melt it down and do layer by layer as it prints whatever object you're printing. So the way this, I don't have power. Yeah, okay. Right. So the way the printer works is it takes filament. So the last filament I used on this was a yellow filament. This comes in an array of colors: red, blue, white, black. So this can be found in many different colors. So basically what I'm going to do right now is I'm going to remove the filament that was there. So to do that, I first am going to heat the nozzle. So just going to heat the nozzle at about 200 degrees. So if you can, just come a bit closer. Right. So let me just go to the main screen. Basically, I control this thing through this control panel. So yeah, if I go to the info screen, it will give me information about the printer. So the bed temperature, this will be the bed. This is where the print sits. And then the nozzle temperature, so I've set it to go up to 200 degrees. Currently it's on 103, 106 and increasing. The reason why I'm doing that is I want to take out the filament, the one that's already there. So if I hit it at the nozzle, it will melt and then it will allow me to basically pull it out. So for the purposes of travel, I have to take out the filament so that we can travel. All right. So this is a one-time setup operation. We don't do this very often. Putting the filament is just once and then we're working. So what I'll do now is I will push in this filament, which will go all the way along the blue tube here up to the nozzle. So I'm at 200. And then I'll just continue feeding it up until I see just at the bottom here, I'm getting blue filament coming out. So you can see I still have the yellow that was in there. So you can see now I'm getting that blue coming out. Right. So from here, I'm going to just take the temperature of the nozzle down back to 0. Go back to the main screen, and from here I can do a normal print. So that was just about setting up the filament. Right. I've not tested it since we brought it in because of travel. It was shaking. But last time I used it, the bed was leveled. So the way it works is the nozzle will be moving around with the aid of, let me just turn off these motors. Right. So with the aid of these motors, so you see here, I'm able to get this motion here. I'm able to get this motion here. And then the bed itself will be providing vertical motion up and down. So the way it works is it's going to do layer by layer by layer. As it prints, you notice the bed will go down and then we'll be printing layer by layer. So I'm just going to start a print here. Let me just start a print for media. So currently I'm printing from this memo card here. This is where my prints are. So if I do print from media, currently there is only one object in here. So it will ask me to start the print, and I'll say print. So what it will now start doing is it will start heating up the bed. So you notice at the top here it says 50 degrees. So the bed, which is where it sits here, it will start increasing the temperature. Once it hits 50, then it will start heating the nozzle. So the way it works, right, is in conjunction with Mr. Owe's CAD lessons, what the students draw on the computer is then converted to a file called STL. Then that file is taken to another software which is called a slicer software. That is the software for this printer. The purpose of that software is to take a CAD drawing, which is a 3D model, and make it into coordinates that this printer understands. So this printer is basically going to be moving right around, placing material where material should be found. So that is what we call additive manufacturing, as opposed to the traditional way of manufacturing, which is what subtractive manufacturing. Remember, if I wanted to make an X, what I do first is I find a big log, then I start chipping away at it until I'm left with the desired shape, isn't it? So additive material, we do not waste material. Additive printing, we don't waste material. What it does is it only places material where they should be material. Otherwise, we don't place anything at all. So going back to my control screen here, each 3D print, when we set it up and then put it on the flash, it is its own settings to say the bed should be a certain temperature. The bed, you can actually feel the temperature if you place your hand on the bed. It's just 50 degrees, so it's not that hot. The bed has to be warm for the initial print to stick on it. Right, so now that our printer is printing, what the 3D printer will do is it will start pulling the material, which is this blue filament, to pull it up through the blue tube, and then it will start layering each and every layer one on top of the other. So in the beginning it will start as though there's nothing there, but then as the print goes on and on, the bed will continually go down, and it will add layers on top of the existing layers. So you notice that is in a nutshell how the 3D printer works. So from our CAD software, as we've normally worked, we'll be basically just taking our 3D model, putting it into a slicer software, which will then create coordinates, right, which will be used by the printer to basically move around and placing material where material is needed. So again, this is what we call additive manufacturing. It's manufacturing where we only add material where material is required. So again, this is called additive manufacturing. The purpose of a slicer software is to convert an STL file into a readable format according to this object. This object doesn't understand what a 3D object is, isn't it? Yes. What it understands is set of coordinates, because it's going to move around and then place material where material is what? Needed. True. So what then happens from there is the slicer software will give this thing enough information to say, for this particular print, not all prints are going to be printed at the same temperature, right? Not all prints are going to be printed at the same temperature. Some you want them slightly different because of different reasons. So you notice the bed here is on 50 degrees. Question?
Yes.
Yeah.
You mentioned that not all of the prints are printed with the same temperature. So does the slicer software decide which temperature is going to be used, or is up to your own discretion?
It's actually both. So the slicer software has got its recommended settings, right? But then you as the individual who's working on a particular project, you have the ability to say, I'm overriding these settings. I specifically want these settings. So if you are printing something so thin, right, you might not want to have a bed temperature that is so high. Why? Because it would wobble and then lift off the bed. If you are printing something that is so wide, you notice that when the print head is a distance away from the other corner, it will take time to go back, isn't it? So you don't want a bed temperature that is so high because it starts lifting off. So you notice, like with any other tool, it takes skill to ultimately get a perfect print. And by the way, it's not really difficult to work with 3D printers. You notice, even if you've got challenges, if you just give it time to work with the printer, work with the slicer software, and I'm actually very confident to say, if I were to give you the slicer software, you would be able to work with it, even though you haven't worked with it before. Just because you're coming from CAD, you'll be able to work with the slicer software. Because what you do is always what I recommend when I teach the slicer software, is set it to recommended settings. Then from there, you can start playing around and putting whatever you want to put, basically experimenting. And then, yeah, in a nutshell, you can change the temperature or you can use the recommended. Basically, with every print, I recommend to pick the recommended settings and then you change their own if there's need to do that.
Yeah. So,
yes.
Is this the smallest version of 3D printer that there is?
No, this is not the smallest.
It's not.
It's not.
So
there are actually smaller ones. I think the Ender 3s are the smaller ones.
Okay.
Yeah.
But what is the biggest scale? And the one I
Industrial, because they're actually 3D printing body parts for cars. They are 3D printing houses. So yeah. So they've actually made 3D printers where I think they put in cement so that it actually prints houses. So they're actually industrial scale printers. Yeah. Look it up. Yeah.
So you talked about the SGL files. So I wanted to ask, how do you feed the CNC machine with the SGL file? Do you use like a flash or something?
Right. So for this particular object, right, if you look just at the front here, you've got 2 ports. This port here has got a memory card, the one that would go into your mobile phone. This is currently what is the information that is happening here. And then you've got another phone, which is another port, which is a classic port, which you'd normally find again on a mobile phone. So for this port here, I can control this printer using my machine if I wanted to print from my machine. But it's always recommended to print from the flash, because you might want to take your machine away. So if you are printing from your machine, then you are stuck to having your machine always be where the 3D printer is. So the way we are printing right now is we're printing from this memory card, which would go into a mobile phone. Yeah. But then the print files, they are really, really small. At most, the biggest print file that I've seen is about 5 megabytes. Yeah, so really, really small. You can fit a bunch on there. Any more questions?
Yes.
Yes, please.
Is it possible to print an object with multiple colors?
Right. Yes, it is possible. I'll start with an alternative, right? For this particular model, you cannot print with multiple colors. It's got one nozzle. When I'm talking about a nozzle, I'm talking about the tip that's melting the filament and then placing it on the top of the existing material. So this one is one. There are other printers that have multiple nozzles. So with those ones, you can actually have multiple filaments connected to this 3D printer. So yes, it's possible. Let's say for the printer that we've got here, you wanted one material to have one color, the other to have another color. One option is to print with one color, take out the filament, put another filament, print with that filament. That's option number one. Option number two is you just print with the same color and then maybe paint it afterwards, like spray paint it. It works as fine. Question?
It was about the specific type of paint.
Oh, yeah. So yeah, well, you can use any other paint. Yeah, I prefer for these small objects to spray paint. Yeah. Question?
Does the model only allow STL files, or it can also allow other files such as FBX, which models can be saved with it?
All right. So that's now the slicer software, right? That's now the slicer software. So the slicer software takes STL. I normally use that one, so definitely I know that one. It takes OBJ, right? FBX, I'm not sure. I'll be lying if I answer for that. But the easiest way to see all the files it takes is if we're to open the slicer software, right? Go file, click open, they need to give, at the bottom you notice it says files of type, isn't it? And they need to give us all the files it can accept. But the bottom line is whatever file type the slicer software, remember the slicer software is what converts the 3D object into an object that is understandable to this printer, isn't it? So in a nutshell, whatever information that's needed by the slicer software, your CAD software already can make that type of file, whether it be STL, OBJ, or any other file. So either way, you're okay. So, do you have a ruler nearby? I just want to
So
do just
that material that you're using, what exactly is it?
PLA.
Is it some sort of plastic, or it's some
PLA,
or some synthetic polymer?
PLA, I believe it's plastic, and I'm not sure. Please don't quote me here. I think it does decompose, so this should be environmentally friendly. Yeah. But please don't quote me here. Look up PLA. So if you say PLA, so it's actually PLA. Yes. Yeah. So the print capacity of this printer, right, is 200. Right, 200 by 200. So this bed would print 200 by 200. So you can print something that is 200 wide. So from my hand here to my fingertip here, you can print something this wide, right? Millimeters, 200 millimeters. In centimeters, that would be 20. So 20 centimeters by a height of 300. So it does print 300. So you can really print big models if you wanted. But remember, the bigger a model, the more material, the longer it takes, isn't it? So that's just something to keep in mind. And as well as you work with the 3D printers, you actually discover more ways to trim down your print time. So maybe, let's say, with the same object, when you print it for 30 minutes, now you'll be able to print for 25 or so. So practice makes perfect, isn't it? Yes. Yeah. So as you can notice, what we once had just as a layer now is that big. So if you really go down, you'll be able to really see as it prints and what it's doing. So remember, excuse me. Remember, I added the filament when I just came in, isn't it?
Yes.
So you notice at the bottom there, it's not really perfect.
Yeah.
But you can see now the level of precision that the printer has as it starts going upwards, because now the filament is coming in at a steady pace. So you'll notice that is the print quality that you should have, that you should normally get. Unfortunately, I forgot. I actually printed a chess set with this type of 3D printer, and it's really doable, right? I think I'll send pictures, Mr. Oye, who will be able to share with all of you. This is a worthwhile machine having.